right, here we go. So this is the plan. Take your computer and log on to Khan Academy. And I assigned an assignment, washer method, revolving around other axes. And I'm now on as you, so we should have the same problems. Fingers double, triple crossed. So get that on your computer and then have a notebook ready to work on the problems. And I'm gonna go over how to do them as we go. It seems like washer method is the one that we're gonna struggle with the most. So not washer method, but revolving around other axes. So I'm not really going over washer method around the X and the Y axis, but it's gonna kind of be implied through what I'm gonna be doing with these problems. So hopefully if you hop in here, you're still gonna feel okay. So I'm gonna be sitting here looking at my problems and then doing them on this whiteboard and hoping that that's going to help guide you through the work. So here we go. I drew the best rendition that I could, blah, blah, blah. So this problem says this region R is the region enclosed by the line y equals 7 and the curve y equals x squared plus 3. So R is this space in here. And they want us to revolve this over the line y equals 2. So everything's drawn. Sorry, my prob was a little bit scooched over too much. So I think about, here's what, I actually sometimes graph this from scratch. I don't love always seeing a picture because then I don't think about what I'm doing. But if this is y equals 2, this is 3 here. So if I'm going to draw a picture of this revolution to see what happens. So if I want to draw this space in orange revolving around y equals 2, this parabola is currently 1 unit above this axis of rotation. So I'm going to go 1 unit below the axis of rotation and draw the mirror image. So I have this, and then instead of y equals 7, I have some line down here. So what I'm looking at is this orange space got revolved around the line y equals 2. And when I revolved, what happened was I'm forming this like circle of a cross section. This is not area, or this is not volume of cross sections, but I can still think about what that cross section looks like. The whole point is I'm going to try to integrate a cross section. I'm going to try to integrate the area of one of these circles. The idea being, if I can find the area of one of these circles and I can integrate all the way from the left intersection point to the right intersection point, if I can integrate the area of all these flat circles, so I can add up all this infinitely thin space of circles, I'll get a volume. It's like stacking an infinite number of papers from here to here and adding up all those areas, I would get volume. I would take something that's 2-dimensional, the area of one circle, and make it 3-dimensional by adding up an infinite number of them. That's what the integrating does for me. It adds up an infinite number of these stacked circles. This problem is made harder for 2 reasons. The first is it's not just circles. So if you watch some of last week's videos, the circles in the beginning they were just circles. Here they're going to have holes in them. So when they're just circles, like let's say I was just rotating this squiggly line around the x-axis, I would draw the mirror image of that squiggly line, and I would have circles that connected the top to the bottom all the way through. And those circles have no holes in them. And when I added up all the area of these circles, I would get the volume of this crazy shape. But if I change what that looks like, and I do squiggles, but I also do a horizontal line, and I rotate around the x-axis, I want to revolve this, show the mirror image underneath the x-axis. Now I have circles still, but I also have inner space that doesn't count as part of the volume. I have to take that out. So this, without the circles, without the space inside, it's called disk method. With this space inside that has to be removed, it's called washer method, because washers look like this. Those little metal things you'd buy at the hardware store to, use when you screw stuff into stuff. So that's why it's called a washer method, because the cross sections here are not just circles, they're circles with holes in the middle. They're donuts, but we don't call them donuts because donuts are like three-dimensional. We call them washers because washers are flat. So I'm adding up an infinite number of these washers. So in this case, I'm integrating not just pi r squared. I'm integrating pi r squared, r representing the outer radius or the radius of one of these outer circles, minus pi r squared, this r being the innermost radius. So I can get rid of the inside so that I truly only have the washer. So I truly only have the space I'm looking for, and the big hole in the middle is still there. All of that to go back to this first one. So I just feel like I wanted to give a little preamble there. So the first reason this is made more difficult is that I have an inner circle. So this is disk method, or I'm sorry, this is washer method, not disk. So I'm going to have a pi r squared minus a pi r squared. That's the first thing. The second thing is, this is not revolved around the x-axis. The x-axis is down here. This is revolved around the line y equals 2. I don't know how Mrs. Mosser taught it, and I went through a lot of ways of teaching it, a lot of different methods before I came to what I felt most comfortable with, which is this. I easily understand how to rotate things around the x-axis. Rotating around y equals 2 is really difficult. So I'm going to just say, you know what? I'm going to move everything I have down 2 spots, 2 units, so that I can just in my mind revolve everything around the x-axis instead. So I'm going to draw a new picture. I'm going to draw a new picture that represents everything moved down 2 units. And I'm doing that because my axis of rotation is y equals 2. I want my axis of rotation to be the x-axis. Well, the x-axis is y equals 0. So I don't want the axis of rotation to be y equals 2. I want it to be y equals 0. So I'm going to do just a translation. I'm going to do just a shift and move everything down 2. And if everything is just moved down 2, in my mind, I can just rotate around the x-axis, and that's all I need to do. This seems like more work than is necessary, but it actually goes pretty quickly. So if I were going to redraw the picture, here are my 2 curves, y equals x squared plus 3. Well, my new curve is going to be y equals x squared plus 3 minus 2. So basically, y equals x squared plus 1. So my new parabola is going to be down here. The line y equals 7 is not going to be y equals 7 anymore. That new line is going to be y equals 7 minus 2, or y equals 5. So my new top of the figure is y equals 5. My new bottom of the figure is y equals x squared plus 1. And my new axis of rotation is not y equals 2, it's y equals 2 minus 2, or y equals 0. That's my axis of rotation. So now everything just moved down. I can revolve this around the x-axis. And I have the same exact shape I had up here. Same exact shape, outer circle, inner circle, everything just got shifted down 2. So what changes is the equations that I use. So I'm going to set up my integral, and I'm going to have, I want the integral of pi times the outer radius squared minus the integral of pi times the inner radius squared. I actually don't need to have it as 2 integrals. I can just do pi r squared minus pi r squared. This is the outer, this is the inner radius. I can also take the pi out and deal with it later. So I'm going to have pi times the integral of this outer radius squared minus the inner radius squared. So what is that going to look like? This is going to be pi times the integral. What is the outer radius? So go to my circle. Have one good representation of the circle. From the x-axis to the outer circle is the radius. So this radius has a height or a length or whatever of that top curve, so 5. And the inner circle has a radius of whatever the curve is in this case, x squared plus 1. This is all with respect to x. That is my formula, my setup. I feel like I made this problem seem way longer and more difficult than it needed to be, but I wanted to go through like the long explanation. So this is the integral you're going to use. I'm hoping as we go through a couple of these, we'll get better and we'll get quicker at it. So maybe you fast forwarded this whole thing. This Khan Academy, when I'm looking back at it, says, what is the volume of the solid? Give an exact answer in terms of pi. So that means we have to integrate this. So now our pictures are done. Now I'm going to integrate it. I'm going to do it by hand because it's good practice. I'm going to do it by hand, especially because it's in terms of pi. I don't know, whatever. Let's just do it by hand and see. So I have the integral of 25 minus x squared plus 1 squared. So minus x to the 4th minus 2x squared minus 1. Right? FOIL this out and distribute the negative. So this is going to become, oh shoot, you know, we never wrote the limits of integration. Sorry, I erased the picture, but we went from -2 to 2. Smallest x to biggest x. Sorry about that. Okay, so we are going to have pi times, let's integrate this. 25 minus 1 is 24, so we're going to have 24x minus x to the 5th over 5 minus 2x to the 3rd over 3. This is all evaluated from -2 to 2. I can already hear you going, why would I not use a calculator? You've got a good point. We'll finish this one by hand and we'll use a calculator for the next. So pi, I'll probably make a mistake somewhere anyway. Plug in 2, I'm going to have 48 minus 2 to the 5th, so 32 over 5 minus 2 to the 3rd times 2, 16 thirds. Oh God. Minus -2 minus plus 32 fifths. My gosh, plus 16 thirds. Why am I doing this? This is really dumb. 48 plus 48, that's 96. Negative, and this is going to be negative 62 fifths. Negative and minus that's going to be negative 32 thirds. Oh my Lanta, why? See, if we were in class together, you would have stopped me. I would have never done this. Oh my gosh. I want to get a calculator because I don't want to do 96 times 15, but I feel like I've committed to the by hand. So now I'm doing it. 45, 48. 1440. I know I'm making a mistake. 62 times 3 is 186. And 32 times 5 is 160. Oh my God, this is such a waste of iPhone space and brain space and everything else. I don't even understand why I'm doing it. 1440 minus 186. Plus, you know I'm messing up somewhere. It always happens. You're probably screaming at the screen right now. Ignore my dog. I don't know, 1094 over 15 pi. Oh my gosh. I'm going to put it in and see what happens. 1094 over 15 pi. Oh, dang it. It says I'm wrong. Oh my God. Okay. This is awful. Screw it. Let's go up here. Okay, let's just put this in. Menu, calculus, integral, -2 to 2. 25 minus x to the 4th minus 2x squared minus 1 with respect to x. How do I... Oh my gosh. I forget how to change things to... What's 0.5333? Isn't there like a fraction to decimal button or something? Oh my God, this is a terrible lesson. It's already, I can't even. Like number? approximate to fraction, 8/15. Okay, so this was 72 and 8/15. So 1088/15. Let's try that in. Yay! Sorry, it was 1088/15. 1088/15. So somewhere I made a small mathematical error. I don't care. That's one problem. Yay! We got through one. I've only been filming for 15 minutes. That's ridiculous. All right, go to the next question. Okay, number 2. Now we're going to go vertical axes. You're going to love it. Just, Okay, so this is one of those things I want to like zoom by and not even worry about, but that would be a total disservice. We just have to get through it, and you have to just take it a little bit at a time and try not to like deep dive into the misery that you might feel. So we have a curve. Y equals x minus 1 squared. We have this vertical line, which is at 1, 0. We have this horizontal line, y equals 4. This intersection point at 3, 4. And they want this section R. And they want that section R rotated around the line x equals 3. So they want me to take that space and rotate it around the line x equals 3. Wow, okay, so they want me to go over there. So they want this rotated over like this, with this space. So I'm gonna have a hole. Now my circles are gonna go the other way. So I'm gonna have this circle and I'm gonna have this circle. So this makes things a little bit more complicated. 2 things, well, maybe 3. First of all, I do have a hole in the middle that I'm gonna have to get rid of. Secondly, I'm not going around the y-axis, so I want to move everything to the left. But when I do this vertical rotation stuff, when I rotate around a vertical axis, when I rotate around the y-axis or a vertical axis, all of my curves need to be in terms of y's, not x's. So I need to basically resolve them. So the equation they gave me was y equals x minus 1 squared. I need to solve this for x, and that's how I'm going to need to use the equation. I also need to use it that way to when I move everything over. So first, let me just get that done. So I'm going to take the square root of y and have x equals the square root of y plus 1. All right, this is the equation that I want to use. Now, I want to rotate. Sorry, my son wants something. I want to rotate this around the line x equals 3, but I don't. I want to back this up. Here's the x and y axis. I want to back this line of rotation up to the y-axis. I want to move it back 3 spaces. So that means that everything I have that's vertical is going to move back 3 spaces. So if I don't really have to redraw this, I can just think that the new equation that I use is going to be x equals the square root of y plus 1 minus 3. And I'm going to revolve around x equals 0, which is the y-axis, which also meant I subtracted 3. So I'm moving everything to the left 3, which I can do by subtracting that 3 once it's already in that form. Okay, so let's see, can we set up this equation without it being awful? So I'm going to have the integral of, I'm going to take the pi to the front, the outer radius squared minus the inner radius squared. The outer radius takes me all the way out to this vertical line. Well, what is this vertical line? How far away is it? Even from this picture, I know how far away it was. This was at 1, 0, and the axis of rotation was at 3. X equals 3. So how big was this outer radius? This outer radius is 2. Even when I shift everything over, the outer radius won't change. The shape itself won't change when I do the shifting. My inner radius is now the curve, which I just manipulated a little bit to make it the square root of y minus 2. This is all with respect to y. And when I rotate around vertical axes, I rotate from bottom to top. I integrate, sorry, from bottom to top. So my bottom y is 0 and my top y is 4. This is what I'm going to integrate. Khan Academy says keep it in terms of pi, so let's see. Zero to 4, so 2 squared minus this whole thing squared. If you would have to FOIL this out because the whole quantity is squared, so let's just keep it in parentheses and put in the square root of, I'm going to put x into my calculator and just tell my calculator it's in terms of x and not tell it that we're really in terms of y. But that was just for our setup. The calculator doesn't care. It's going to do this integration either way. So here we go. So we have this number times pi. So I got 13 1/3 pi. To put it in Khan Academy, I'm going to go 39 40/3 pi. And let's hope that we get it right. 40/3 pi. Yay, pretty sound. Okay, that you might feel a little overwhelmed. Let's just keep going. Sometimes one of my favorite quotes is, action is worry's worst enemy. We can sit around and worry about this and you can think, oh my gosh, that seemed way too difficult. Or we can just keep moving forward. And sometimes moving forward actually gets you where you want to be, even though it feels a little overwhelming. Oh my gosh, this is a log one though. Do we really want to do the log one? Where are we going? No, because I don't really want to do a log around the line x equals 2. Well, you know what? We have to. We have to fight through the things we don't want to do. Okay, let's see. We've got the line x equals 2. We've got the line y equals 1. We've got the curve y equals log base 2 of x. And we've got a vertical line x equals 8. This is a solid. The space inside is, they're calling it R. So this space in here, I don't really need any of this. If you don't have a whiteboard's a great spot to do some of this work on. I'm just going to write the x equals 2 there, and I'm going to write this as 8 so I remember. And I want to revolve this around the line x equals 2. Okay, so here is my axis of rotation. So that means this is going to go over here. I'm going to have like this, like this, like this. Here's the reflected space, and my circles go from bottom to top. So here's the outer radius of the circle, or the outer circle, here's the inner circle. Now, if this was around the y-axis, my setup would be a little bit easier, but I'm not, so I have to do two things. Because I'm rotating vertically, I want to rewrite that equation in terms of x. So this equation, how do you do logs? How do you solve for x? Well, by basic definition of a log, this base raised to that power equals that number. So 2 to the y equals x. There's my new equation. That's what I'm going to use instead. So this is x equals 2 to the y. That's what this is. Okay, this is still x equals 8. Now I want to shift everything so that I'm not rotating around the line x equals 2. I want to shift everything to the left. So the new equation I want to use is going to be x equals 2 to the y minus 2. Okay, so let's set up the integral. So we're going to integrate from bottom to top. So the bottom is 1. The top is a y value of 3. I know that because I see this point 8, 3. And I'm going to take the outermost radius squared minus the innermost radius squared. The outermost radius, I don't have to move it over to figure out how big this radius is. even from the original picture, mx equals 2 here, mx equals 8 here. That radius is 6. The inner radius, I have to use the new equation shifted, 2 to the y minus 2 with respect to y. Now, that's my answer. I'm doing Khan Academy with you, and obviously they're asking me to just set it up. I don't see the answer. Well, first of all, can't we kind of know the answer is going to be B because it's the only one that goes from 1 to 3? But their answer, their integration doesn't look like mine at all. I would love to just put theirs in my calculator and mine because they just did some manipulation. So let's just do that and double check that everything works out. So let's put mine in the calculator. I get 55.3438. I'm going to put their choice B in the calculator, which looks like this is what it should be. It's the only thing going from 1 to 3. So they have negative 2 to the 2x plus 4 times 2 to the 2x plus 32. Just double checking that. Negative 2 to the 2x plus 4 times, oh, whoops. Yep, same thing. So what did they do? Why does theirs look different? They FOILed this out and then they added the 36 in there or whatever. So that's what they did differently. Foiling this out seems like a waste of time because it is a little bit annoying with the 2 to the y. So this turns out just fine. Yay! All right, here we go, B. All right, let's look at the last one. Every time you think the videos get too long, just remind yourself how long school used to be, and you know, if you just sit through the half hour or whatever long video. I know it's annoying, but it just is what it is. Okay, so let's see. They use colors, which is nice, but still it's sometimes hard to see. So we've got y equals x, and we've got a curve. They meet up. And this point is 1, 1. And I've also got, dang it. Oh no, okay. The line that comes here, this is x equals 3. So the region enclosed by y equals x, this curve, which is y equals e to the x minus 1, and the line x equals 3. So I've got this area, and it is getting rotated around the line y equals negative 1. Of course it is, because they hate us. So going around the line y equals negative 1. Well, the good news is I don't have to change the way anything's written. Everything can stay just like that. So I'm going to be going from here to here. So from here to here. If you want to draw it, go for it. So this would be coming this way. And then this, instead of going like this, would be going like that. Oh, God. Nope. Let me try that again. Okay. Decent. Not very great. So I have outer circle, inner circle. I think it's important to draw so you can see what the outer and the inner are. Now the only thing I don't like is I don't want to revolve around y equals negative 1. I want to shift everything up 1. So shifting everything up 1 means this is going to come up to the x-axis. So our axis of rotation is going to be up. Obviously this is not drawn to scale at all. This is supposed to be the halfway point. Oh God. Okay, my picture is not great. But that means this curve is going to become y equals x plus 1 because I'm shifting everything up 1. This is going to become y equals e to the x minus 1 plus 1. And everything's getting shifted up like that. So here we go. We got our integral of, got pi radius squared minus radius squared. The outer radius is the one that comes all the way up to this curve. So that's this, e to the x minus 1 plus 1. Our inner curve comes up to this line, which is now x plus 1. My circles are going this way, so I need to add them up from left to right. So from x equals 1 to x equals 3. And there's my integral. It's supposed to match one of theirs. Let's do the foiling out so we can just see how it matches. Although that's actually really gross, isn't it? Ugh, who wants to foil that? I don't think you need to foil that. The AP test isn't going to ask you to. So let's see which one matches theirs. All right, they have two answers that go from 1 to 3, so it's either A or it's B. Looks like it's going to be A, but I guess I will foil this. I'll do some gentle math here and see if I can get it. So if I foil this, e to the x minus 1 plus 1 times e to the x minus 1 plus 1. You might think like that's a total waste of time, but it's not a bad idea to remember how that foils. So when I multiply e to the x minus 1 times e to the x minus 1, I add powers. So x minus 1 plus x minus 1 becomes 2x minus 2. And now e to the x minus 1 times 1, and my inners, and my lasts. So there's the first part foiled, and now let's foil the second part, and don't forget to distribute the negatives. So minus x squared minus 2x minus 1. So if I really put that together, pi times the integral of e to the 2x minus 2 plus 2 e to the x minus 1 minus x squared minus 2x, and those cancel. So this is the same as A. Yay. Okay, so those were the 4. I'm hoping you feel a little less panicked than you did even after the first 2. Maybe you're feeling a little bit better. So I'm hoping you go print these. We're going to keep referring back to 1, 2, 3, these 4 questions, and we're going to do little bits of each. So for today, I want you to go take problem 2013, and I want you to do part B. So it's the volume of the solid when we rotate around y equals 4. I also want you to take the one from 2014 and do part A. Those 2 parts are what we just went over. So hopefully you feel comfortable with them. We didn't talk at all about area under a curve. So I want you to go and also do 2013 part A. This is just area under a curve. And 2015 part A is also area under a curve. Okay, I'll do the videos of those in just a minute. Yeah, you got through it. If you did, 33 minutes and 33 seconds. Good job.